This is Inequality IGCSE math questions. Let's take a look at question after question, and we see how to solve inequality problems, and then probably we move to other topics. Now let's first of all copy this question. 3n minus 11 is greater than 5n minus 18. So we have 3n minus 11 inequality. So we're starting with inequality first, so we write inequality first. Inequalities. Question number 1. We say 3n minus 11. I think is greater than, right? For the question, minus 11 is greater than 5n minus 18. Is greater than 5n minus 18. Okay, what we do, the first thing we do is to collect like terms. Okay, we try to collect like terms. When we say collect like terms, we mean the terms that has n in them, we bring them to one side. The terms that do not have n, we bring them to the other side. Just like we do simple equation. So you see we have 3n. We look on the right side, we have 5n. We bring it to this side, it's going to be minus 5n. Then it's greater than. You write the negative 18 first because it's on the right. We write the negative 18 first. So we say it's greater than negative 18. Then we bring the negative 11 to this side. So when it crosses this, it becomes positive. So negative 11 comes to this side, becomes plus 11. That's the first step. Like collect like terms. That's the first step. Collect like terms. Collect like terms. That's the first step. Now the next step is to begin to evaluate. 3 minus 5 will be negative 2n, right? 3n minus 5n. That will give us negative 2n. Is greater than. Now negative 80 plus 11. That will be negative 7, right? Negative 18 plus 11 will be negative 7. So we're looking for n. Since we're looking for n, we're going to divide both sides by minus 2. So we're going to divide both sides by negative 2. So if we divide both sides by negative 2, I'll divide here by negative 2. We'll likewise divide here by negative 2. So negative we cancel negative, 2 we cancel 2. This negative also cancel this negative. 7 divided by 2, we get 3.5. So we get n greater than 3.5. Now, whenever we divide by negative, this greater than will become less than. Right? So whenever we divide by negative sign, this greater than sign will become less than. So here, this one will become less than. Why? Because we divide by negative. In inequality, once you divide by negative, this sign will change to the opposite side. If it was greater than before, it becomes less than. Is that okay? If you want to see how that plays out, we can do it in another way to see how that plays out. If you say 3n, let's change the color. Let's say we take green. 3n minus 11 is greater than 5n minus 18. So if we bring minus 18 to this side, become minus 11. Minus 18 comes here, become plus 18 because it's minus on the other side. So when it comes to the left, it becomes plus 18 is greater than 5. You write the 5n first. 5n. When this one comes this way, it becomes minus 3n. It was plus 3n on the right, on the left. It comes to the right, becomes minus 3n. So this one we get regular 7. We get 7 is greater than 2n. Okay, 7 is greater than 2n. So because we're looking for n, we divide both sides by 2. So if I divide here by 2, I likewise divide here by 2. So I'll get 3.5. We get 3.5 is greater than n. 3.5 is greater than n. Yeah. Now 3.5 is greater than n. If you say 2 is greater than n, it's same way as saying that n is less than 2. It's same. It's just that you say this cup is half full. Another person can say it's half empty. It's the same thing you're saying. One say, oh, it's half full. The other one says half empty. So it's the same thing. So when you say 2 is greater than n, same as n is less than 2. If you say 3.5 is greater than n, it's the same as saying n is less than n itself is less than 3.5 because 3.5 is greater than n. So that's what we got when we did it the other way around. So that's why we get n is less than 3.5. So in a nutshell, what I'm trying to say is that whenever you have you divide by negative, then if we flip this sign to the opposite side. Is that okay? Now let's take another question. Question number 2. Question number 2. And let's see this inequality. Solve this inequality. X plus 13 is greater or equal to 3x plus 7. X plus 13 is greater than or equal to 3x plus 7, right? Let's check. Yeah, 3x plus 7. Okay, let's solve this question. Now, like we said, collect like terms. So if I bring 3x to the right, I will have x minus, because when 3x comes to the left side, it becomes negative. So it becomes minus 3x. Then it's greater than or equal to, you write this 7. Okay, ordinary numbers should go one side, numbers with letters should be on one side. So this 7 is here, then 13, bring it to this side, become negative minus 13. So x minus 3x will give you negative 2x. Will give us negative 2x. Greater than or equal to 7 minus 13, that will be negative 6. That will be negative 6. Okay, like we said, you divide both sides, because we're looking for x, you divide both sides by minus 2. We have to divide with everything that is with x, so that only x will remain on the left. So I divide here by negative 2. Then I also divide the right side by negative 2. Now, anytime you divide by negative, like we said, this negative 2 we cancel this negative 2. Only x will remain here. Anytime we divide by negative, this sign we flip. Instead of greater than or equal to be lesser than or equal to. To be lesser than or equal to. So this negative we cancel out this negative. 6 divided by 2, we will get what? We get 3. So x is lesser than or equal to 3. And we can show this in a number line. So if I draw a number line, even this first one, we can also show it. Okay, if you draw a number line, let's say here, you have like -2, you have -1, you have 0, you have 1, you have 2, you have 3. Okay, let's say you have 4. Let's extend it to 4. Okay, these are your number in the number line. And then the inequality says x is greater than or equal to, x is lesser than or equal to 3. So you go to 3. You draw this. Because it's lesser than or equal to, we go to shade it. If it's only lesser than, we're not going to shade it. If it's lesser than or equal to or greater than or equal to, we have to shade this place. We shade this. And because it's lesser than, it goes to this direction. And then you show with an arrow. So this is this x-axis, and this is for the inequality. This is for the inequality. X is lesser or equal to 3. X is lesser or equal to 3. You go to where 3 is. If it's lesser than, you have to go to your left. And because it's lesser than or equal to, you have to shade here. If it's only lesser than, we will not shade. We'll just draw a circle only. Okay, so that's what happens. And then for the first one we did, let's do the same inequality for it. Okay, so we say 3.5. Let's say, for example, we have -2, -1, 0, 1, 2, 3, 4. So obviously 3.5 is here in the middle between 3 and 4. So 3.5 is there. So this one, you see n. So this is an n function. N is only lesser than 3.5. So we're not going to shade. We'll only draw a small circle here. Because it's lesser than, if you look at it with your left hand, you will know the direction to go. Okay? So you go to the left as well. You go to the left. It doesn't matter where you stop. And then you just show with this arrow that is going this way. So this is the inequality for the first one, and this is the inequality for the second one. Is that okay? Hello, are you there?
Yes.
Okay. Are you following?
Yes.
Okay. Now let's take another question. It says list the positive integers that satisfy the inequality in part A. This is part A, and we said the solution was x was less than 3, lesser than or equal to 3. So the positive integers are 1, 2, and 3. So if they say list the positive integer that satisfy this inequality, the integers are positive. You know, integers are whole numbers. Integers are whole numbers. So they could be positive whole numbers and also could be negative whole numbers. That's why we have negative integers. If you have -1 is an integer, but it's a negative integer. We have -2 is an integer, -3, -4, -5, as long as they are whole numbers, so they are integer. But this question says we should list the positive integers that goes with the solution. This solution, we said s is lesser than or equal to 3. So the positive integers are 1, 2, and 3. These are the positive integers. Why is 3 inclusive? Because x is lesser than or equal to 3. So it's also equal to 3. If the answer was just s is less than 3, the only integer would have been 1 and 2. If our solution was like this, for example, if our solution was x is less than 3, then the only integers will be positive integers will be 1 and 2 only. But because they say x is lesser or equal to, this symbol means less than or equal to. So when you say x is less than or equal to 3, meaning you're going to list 1, 2, and 3 as the integers. So we've answered this question that asks us to list the integers that goes with the part A that we've solved. Now let's go to another question. Here is a find the positive integers that satisfy the inequality. So we have to solve the inequality first, and then we'll be able to find the integers that satisfy this inequality. Now let's write t plus 2 is greater than 3t minus 6. T plus 2 t plus 2 is greater than 3t minus 6. So first and foremost, we have to solve this inequality, and then we find the positive integers that satisfy the inequality. First of all, we find the inequality, solve the inequality, solve for the value of t, and then we find the positive integers that satisfy this inequality. So by so doing, like we said, we collect like terms. We say t, this minus 3t will go to the left. It becomes, this 3t will go to the left, and it will become minus 3t greater than, now negative 6 on the right. Bring all the numbers only to the right. Bring all the numbers only to the right. And then bring this minus 2 to the right, becomes plus 2 on the left to the right. It will become negative 2. So t minus 3t is like 2t. What that means is that you have one pen or one table. Let's use t for table or anything. You have one table, you're owing people 3 tables. If you give your one table, you're still owing 2 tables. Okay, so we say negative 2t is greater than negative 8. You got minus 6 minus 2 is minus 8. So this gives us negative 8. So the next thing to do is to divide both sides by negative 2. Why? Because we want to find t. So we have to divide any coefficient of t has to be divided. You have to divide both sides with the coefficient of t. Negative 2 is the coefficient of t. So we have to divide both sides with negative 2 in order to find t. So I divide here by negative 2, and also we divide here by negative 2. And then this negative 2, we cancel this negative 2. So only t remains on the left. Only t remains, which is what we are looking for. And then we say anytime you divide by negative, this greater than will change to less than. We swap. Okay, this symbol of inequality will change. Because t is less than, minus divided by minus become plus, and 8 divided by 2 we get 4. So we get t is less than 4. So the positive integers are 1, 2, and 3 only. 1, 2, and 3. Because 4 is not part of it. Why? Because we say t is less than 4. T is less than 4. 3.5 would have been part of it, but 3.5 is not an integer. Only whole numbers are integers. Okay, decimal numbers are not integers. So these are the positive integers, okay, in this inequality. And if we want to show in a number line this inequality, we just sketch. You can start from 0 if you like. 1, 2, 3, 4, 5. Any number, from any number to any number you like. But when you are drawing it, you go to the 4, because the t is less than 4. So this is our t, you put it here. You go to 4. Since it's only less than, you just draw a circle on top of it. And less than, you go to this direction as well. So this is our inequality for this problem. And these are the positive integers for this problem. Okay, now let's take another question. So they are similar now. So I think we look for harder ones, right? Or something different. Even if we don't use the term harder ones. Something different. Is it okay? Okay, let's try this one. Okay, we have 6n plus 3 is greater than 8n. Question number 4. Are you there?
Yes.
Okay. We have 6n plus 3 is 6n plus 3 is greater than 8n. Okay, this is also similar, it's just that we don't have another number standing with this one here. So we still do the same thing, we collect like terms. So we say 6n. Bring this one this way, become negative 8n, because you bring it to the left. From the right side, you bring it to the left, it becomes minus 8n. That is greater than this 3, bring it to the right, it becomes negative 3. Okay, so 6n minus 8n, we're going to get 2n. Negative 2n. So negative 2n is greater than negative 3. So to find n, we have to divide both sides by negative 2. Divide both sides by negative 2. So when we do that, we have here divide by negative 2. And then we have here divide by another negative 2. So this cancels this. We have n left on the now, because we are divided by negative, the sign will change, right? The sign will change. From greater than, it will change to less than. To change to less than 1.5. This one will cancel this one out. 3 divided by 2, we get 1.5. We get 1.5. N is less than 1.5. So we can likewise do the number line as well. If you have minus 2, minus 1, 0, 1, 2. So obviously 1.5 is at the middle here. So we draw here, we put a circle, is only less than here, and it's going this way. Okay, it's not all the inequality that goes to the left. Okay, if you have greater than, it will go to the right. Okay, if we have inequalities like this, like we say, let's say x is lesser than or equal to, is less than 5, and is greater than or equal to 2. If we have something like this, if we have a solution like this, which we're going to do a lot of problems like this as well. If we have a solution like this, then your number line will be, let's say you have 1 to 5, 0, you have 1 here, you have 2, you have 3, you have 4, you have 5, and then you have 6. Let's say these are your number, and this is your x. Okay, so this inequality say x is less than 5, so you go to 5, is only less than, so I draw only a circle on top, and greater than or equal to 2. The same x is greater. See, remember this one, 2 is less than or equal to x, is same thing as saying x is greater than or equal to 2. If you say 2 is less than x, it also means x is greater than 2. It's the same thing. If you say this boy is younger than me, it means I'm older than the person. It's the same thing. So we come to 2. We say x is lesser than 5 and is greater than, the same x is greater than 2, greater than or equal to 2. Since this one for 2 is greater than or equal to 2, we have to shade here. And then we join both of them together. So this type of double inequality, this is how we draw their number line. This is how we draw their number line. We're going to see a problem like this, and that we expatiate that. We'll be able to show this clearly when we see a problem like this. Now let's take a look at each or more problems. Let's look for more problems. Okay, this one is good enough. So we have solved the inequality. Solve the inequality for positive integer values of x. So let's 21 plus x over 5. 21 is question number 5. Question number 5. 21 plus x over 5. 21 plus x over 5 is greater than x plus 1. Is greater than is greater than x plus 1. Okay, this is another inequality. What we can do here, since this one is in fraction, what we can easily do is to eliminate this 5 in the denominator. To do that, I can multiply here with 5, the left side, and also multiply the right side with 5. So I can multiply the left side with 5, as well do the same thing to the right side. You know, whatever you do to the left, you must do to the right. So I multiply through with 5. So that this 5 here can cancel this 5 here. The whole reason is to eliminate the denominator. Why we multiply both sides with 5? Okay, the question is multiply both sides with 5. That's the first thing. So I do that, and then we get what? On the left, we only have now 21 plus x. Because the 5 on top, we did cancel out the 5 at the bottom. So I have 21 plus x is greater than. Now you expand this one. You have to expand 5 times x. You have 5x. You have 5x. The 5 outside multiplied by everything inside the bracket. So you have 5x here. Plus 5 times 1 is 5. So plus 5 times 1 is 5. You have 5 here. So it becomes a linear inequality. It looks like what you're used to. So when you have this now, it looks like. So the next is to collect like terms. We say collect like terms. We collect like terms. What do we mean by like terms? Numbers with letters, we bring them together in one place, one side. And then ordinary numbers, we take them to the other side. That's what we mean by like terms. The ones that are alike, bring them to one side. So we have x. Then on the right, we have 5x. So we bring it here. If it comes to the left, it becomes negative 5x. Becomes x minus 5x is greater than 5 on the right. Just a moment. Is greater than 5 on the right minus 21. You know, 21 on the left, when it comes to the right, is going to become negative. When it crosses this greater than sign, it's going to become negative 21. So this one we have x minus 5x is like you have 1 ringgit, and then you are owing someone 5 ringgit. When you give to the person, you still owing 4. So x minus 5x, it becomes negative 4x. Negative 4x is greater than 5 minus 21, 16, negative 16, right? Negative 16. Now the next is to divide both sides by negative 4 so that we can find x. Divide both sides by negative 4 so that we can find x. So we divide here by negative 4. And then we also divide the right side by negative 4. You know, remember, whatever you do to Hassan, you have to do for Hussein. So whatever you do to the left side, you must do to the right side. So then this negative 4, we cancel this negative 4. Only x will remain here. And I say anytime you divide by negative, this sign will swap. Will become lesser than. It used to be greater than, it becomes lesser than. 60 divided by 4, we get 4. So x is less than 4. We show the number line, we also show the positive integer. If x is less than 4, then you see if we have 0 here, we have 1 here, we have 2 here, we have 3 here, we have 4 here, we have 5 here, we have 6 here. So x is less than 4, you come to this place, you draw only a circle, you don't shade it, you go to the, since less than that is going to the left, you go to the left. Okay, so that's that for the inequality. Now they want the positive integer. The positive integer are 1, 2, and 3. Because they say x is less than 4. 1, 2, and 3 are the positive integer for this problem. Now we'll move on to next question. Is it understood?
Yes.
Okay, great. This one is similar, right? We jump this type of question. Let's come here. Let's take a look at this one. X over 2 plus x minus 2 over 3 Question number 6. X over 2 minus x minus 2, sorry, x minus 2 over 6, right? X minus 2 over 3 is less than 5. X minus 2 over 3 is less than 5. Okay, the first rule in mathematics is thou shalt not fear any problem. The problem students have when they see questions, they start to shake. Especially when they feel it's not familiar. It's not, you don't have to shake. All these things have same rules. Just follow the rules, that's it. Now, for example, if I want to remove the denominator, because I just want to remove the denominator and make it look like a linear function or linear inequality. So to do that, you have to find the LCM of the denominator. So we multiply here by the LCM, multiply the whole of this fraction by the LCM, multiply this one by the LCM. The LCM of 2 and 3 is 6. It's just like you say 2 times 3 for this particular problem. The LCM of 2 and 3 is 6. So we multiply through by the LCM of the denominator. So the LCM of the denominator is 6. 2 times 3 and 1. 2, 3 and 1. The LCM is 6. So what I will do is to multiply each of the term with the LCM to remove the denominator. The reason is to remove the denominator. So you see what we're going to do now. We say x minus 2 over 3, but we're going to multiply each one by the LCM, and we've agreed that the LCM is 6. Now since the LCM is 6, it means I'm going to use 6 to multiply. I'm going to use 6 to multiply this place. I'll say multiply by 6. The whole of this fraction, I'll multiply by the LCM of the denominator. Say multiply by 6. And then here, I say multiply by 6. That's it. That's the first step. So the first step means multiply through by the LCM. Multiply through by the LCM of the denominator. Multiply through. Why we use the word through? Meaning all of them. Meaning all the fraction. You have to multiply them by the LCM of the denominator. By the LCM. This is not the only way, okay? But I feel this way is easier. Of the denominator. Of the denominator. Okay, so when we do that, you see that 6, these 2 divide by itself, you get 1. This 6 divide by these 2, you get 3 here. So I have 3 here now. Then this 3 goes into itself, you get 1. 3 divided by 3, you get 1. 6 divided by 3, you get 2. So the next step is to now expand what's remaining. This 3 multiplied by x, I have 3x here. Minus, there's 2 outside the bracket here. This 2 times x, you get 2x. This 2 times negative 2. See, this negative times this negative become plus. This negative times this negative is plus. And then we get a plus 4 now. Is that okay? We get plus 4. Is less than 5 times 6. We get 30. So it has become only one step we took by multiplying through with the LCM. You see, we get a linear function. The next is to collect like terms. So we say collect like terms. collect like terms. Now, meaning what we mean by collecting like terms is like we've always said, the ones with the variables with coefficient, we bring them together. So 3 is like saying 3x minus 2x. They are in one side, so the sign doesn't change. And then it's less than 30. You bring 4 to the other side. It becomes negative 4. So 3x minus 2x is x. Is x less than 30 minus 4, you get 26. So this one, as easy as possible, became this. So if this question wants us to list all the positive integer, we're going to list 1 to 25. We're going to mention 1, 2, 3, 4, 5. So you can just say 1 to 25. All the positive whole number 1 to 25. So that gives us the solution to this problem. Now let's move on quickly. We want tougher problems. Think this one is similar to what we used to, right? We leave this type, right? Am I right? Can do this one, right? Hello? Hello, are you there? Is it me? Hello?
Yes.
Are you sleeping?
No.
Okay. I said this one, see this last question for this first phase is the one you're used to. So we jump to harder questions, right? Right? Or you want me to solve this one?
No, it's okay.
Okay. So we finished the first one. We have different type. We're going to open another one now. No. Inequality. No. Okay. Okay, let's find some inequality questions from here. Right from here. This one is variation. So we keep the variation problems for later. Let's see anyone that has this variation. This variation. Yeah, remove variation. Okay, look at inequality. Look at inequality question from the exam mate. Okay, let's solve some questions from here. Are you with me? So
yes.
we write this 6 into 2 minus 3x. 6. Question number 7. Six into 2 minus 6 into 2 minus 3x. Two minus 3x, close the bracket, minus 4 into 1 minus 2x into 1 minus 2x. We close the bracket, is lesser than or equal to 0. Lesser than or equal to 0. Okay, the first thing we do is to expand, and then we collect like terms. So it's not a big deal. It's to expand. We already learned expansion in algebra. So we expand. We take this 6 to multiply everything inside this bracket. We take this negative 4 to multiply everything in this bracket. We equate, or we say lesser than or equal to 0, and then we collect like terms after expansion. Okay, it's just a step-by-step process. So what you do is just to say 6 times 2, 12. You got 12, right? 6 times 2, we say 12. Then minus 6 times negative 3x, we get negative 18x. Negative 18x. And then we're done with this. We've used this 6. We've used this 6 to multiply everything in this bracket. That's what we've done. We are done with this. We've expanded this. 6 times this 2, 6 multiplied by this 2, we got 12. 6 multiplied by negative 3x, we got negative 18x. Then the next one to do, the next thing for us to do is to use negative 4 to expand everything inside this second bracket. So you say negative 4 times 1, it becomes negative 4. Then negative 4 times negative 2x, it becomes positive 2x. Sorry, negative 4 times negative 2x, we get positive 8x, right? Because 2 times 4 is 8. We get positive 8x. Then we say everything is lesser than or equal to 0. Now we collect like terms. The one with x, we put them in one side, and the one with ordinary number, we take them to the right side. So you have negative 18x. And then here we have positive 8x. This positive remains because they are both on the left. It's not coming from the right. If it's coming from the right, the sign will change. Remember, it's just on the left, so it's not going to change. It's still the same thing. Then you write greater than or equal to, then bring all the ordinary number to the right. Positive 12 will now be negative 12. And negative 4 will now be positive 4. So we now evaluate. The next is to evaluate each of them. We evaluate this. And likewise, we evaluate this one. So negative 18 plus 8 will be negative 10, right? Like you are owing someone 18 ringgit or 18 riyad. And then you have 8 riyad, you pay, you still owing 10. So it will remain 10x. Is lesser than or equal to negative 12 plus 4 will be negative 8. Right? Negative 8. So if we divide both sides by negative 10, I'll divide. If we divide both sides by negative 10, divide here by negative 10, also divide here by negative 10. This negative 10, we cancel this negative 10. We have x left on the left. And remember, we said that when you divide by negative, this one will change to greater than. It's less than, now it will be greater than or equal to. To be greater than or equal to. Negative divided by negative become positive. 8 divided by 10 becomes 0.8, right? Becomes 0.8. So x equal to 0. S is greater than 0.8. So if you draw a number line for this, let's say you have 0.0, 0.5, and then you have 1. You have 1.5 here, and then you have 2, for example. If the 0.8 will be somewhere here, so we say s is greater than or equal to. So if 6 is greater than, we go to shade this place. We go to shade it. Is greater than or equal to 0.8. 0.8 is here. Then if you go this way, because it's greater than or equal to, if you go this way, on to the right. So this is the inequality. Is that okay for this question? Okay, is that okay? Yeah. See, x is greater than s is greater than or equal to 0.8, or you can write in the fraction. 0.8 is same as 4 over 5. So you can write 0.8 in decimal, leave your answer in fraction. So that's that for that question. Now let's take another question. Here comes another one. Solve the inequality. 6. Is it not the same thing? They repeated this question. 6 into 2 minus 3x minus 4, 1 minus 2x is same thing. Let's go to another question. Okay, let's see this one. Solve the inequality. 2x plus 5 is less than x minus 1 over 4. Question number 8. Question number 8. 2x plus 5 is less than x minus 1 over 4. 2x plus 5 is lesser than x minus 1 over 4. Okay, you know we've done a similar question like this from Save My Exam. Now what we should do is just to multiply both the left side and the right side by this denominator, right? Just multiply both sides by the denominator. When you do that, then you set yourself free. Multiply both sides by the denominator. By the LCM. The LCM, you know this is over 5. Okay, the meet is saying 5 minutes remaining. So after like 4 minutes or okay, say 10 minutes, 9 minutes remaining. After that, we'll send you another link, okay? Okay?
Okay.
Yeah. So we multiply both sides by the LCM. What's the LCM? Because this is just a whole number. Every whole number you can say over 1. So 1 and 4, the LCM is 4. So we're going to multiply both sides. LCM is 4. We're going to multiply both sides with 4. So what I have here would be 2x plus 5. So I'll multiply my left side with 4. Is less than. The reason why we are multiplying both sides with 4 is to remove the fraction. X minus 1. Sorry. X minus 1 over 4. Then we're going to multiply the whole thing with 4. When we do that, the 4, we cancel this 4, we cancel the 4 at the denominator. So we now have this. We expand this one. 4 times 2, x becomes 8x. 4 times plus 5 becomes plus 20. Then we say less than. What we have here, this 4 cancel this 4. Only what we have is x minus 1 on the left. On the right, sorry. X minus 1. So now this becomes looks linear. What we should do is now to collect like terms. So we collect like terms as usual. Collect like terms. Collect like terms. So which means I will have which means I'll have 8x. I bring this x to this side because negative x. 8x minus x is less than. I have negative 1 here already on the right. I have negative 1. Then I'll bring this one here, it becomes minus 20. So 8x minus 1 is 7x. So we simply say 7x is less than negative 21. Because minus 1 minus 20 is minus 21. Here, we are not divided by negative. We are only divided by 7. So we divide both sides by 7. So this sign will not change. Remember, this sign will only change when you divide by negative. So here we are only divided by 7. So if you divide by 7, what you have here is 7 will cancel out 7. Here, you divide by 7. So this one takes this one out. X remains only on the left. And then less than. What do you have here? Minus 21 divided by 7, we get minus 3. Minus 21 divided by 7, you get minus 3. This sign will not change. Reason be that you did not divide by negative. We didn't divide by negative, so this sign, this less than sign will not change to greater than sign. To remain as less than. Okay? This sign will remain same. And this will be our final solution for this question. And if they ask you for a number line, I'm just adding that as an addition, okay, for you. As we treat every question, we draw the number line. It's better for us. Then after we finish, then we start the number line as a subtopic. So this one, we have minus 4, we have minus 3, we have minus 2, we have minus 1, we have 0, we have 0, and then we have 1. So the question is x is less than negative 3. So you go to negative 3 here. X is less than it. So you go this way. This is our number line. This is the x-axis. So x is less than negative 3. This is it. This is the number line in case you're asked to do that. Now let's take another question. See, x is less than negative 3. That's the solution to that question. Okay, let's see another question. Oh, this variation. P varies inversely as n plus 1. This one we'll do later when we do variation, maybe probably tonight. And this factorization, this is so there's no inequality here, so we jump this question. Okay, we have inequality here. Because these questions are from IGCSE paper. They just take them from IGCSE paper. Okay? They just take the question from IGCSE paper. So we treat only the inequality question here because we are after inequality questions. Okay, the question previously, I think if we scroll down, we'll see inequality question. Let's say we scroll down, maybe there's inequality question. Okay, there is. So there's inequality question in the so because they just copy and paste the whole question, they put it as a page. Okay, so let's solve the inequality. This one. So question number 9. Question number 9. Five into x minus 4 is less than 3 to 12 minus x. 5 into x minus 4 is less than 3 into 12 minus x. Take this as the question. 5 into x minus 4 is less than 3 to 12 minus x. So let's solve this. Okay, this is the question. So what we just need to do is to expand. Expand this, expand the left, and expand the right side. Then we collect like terms, as usual. It has similitude, the same way, the same principle. If it's in fraction, you multiply by the LCM throughout. Multiply throughout by the LCM, then you expand, then you collect like terms. If no fraction, if it has bracket, you just expand, then you collect like terms. So it's straight away. 5 times x, we have 5x. 5 times negative 4, we have negative 20. Is less than 3 times 12, we have 36. Can you see? Hello? Let's see another.